Hello everyone, welcome to my channel. In this video, I would like to evaluate the integral of cosecx using simple algebraic technique, and then I'll bring up another video where I'll evaluate the same integral but using what we call the z substitution. So let's look at how we evaluate this integral then using simple algebraic technique like I said. Right, so the approach is as follows. The integral of cosec x dx. Now, just to remind you that this is the same as 1 over sine x dx. So cosec is actually 1 over sine x. Right, now I want to perform a simple technique here that I've used in so many videos so far on integration, which is called the special one. I'm going to apply the special one here as well. So this is the same as the integral of 1 over sine x times sine x over sine x dx. Now sine x times 1 obviously is sine x, so this is integral of sine x all over sine squared x dx. Remember, trig identity, sine squared plus cos squared equals 1, and therefore this should give you, let me just remind you on a separate page here. I'm basically saying that we have an integral that I've used before. It says sine squared of x plus cos squared of x equals 1. And so from here, if I want to make sine squared of x subject to formula, I'm going to say sine squared of x is equal to 1 minus cos squared x, like that. So this is what I'm going to use. So that should be replaced by that expression. Now this is equal to the integral of sine x all over 1 minus cos squared x and dx. Now remember, this is the special one I spoke about. You can cancel this and you're back to the original integral, which is 1 over sine x, which is actually cosec x. Now at this stage, I'm going to let u be equal to cos x because I see sine x in the numerator. But when I differentiate cos x, I get minus sine x. So I must do something in the numerator first. So I'm going to do the following. Check this, minus the integral of minus sine x all over 1 minus cos squared x dx. Now the minuses will give you a plus sign obviously, but I know that when I differentiate cosine, I'll get minus sine x. Let's go to page 2 now. Let me move this one down. Right, yeah. So now what I'm saying is, at this stage we're gonna say, let's use another letter. I can use u, but if I want I can use another letter, but let me use u because u is very famous. Let u be equal to, check this out, cos of x, and therefore if I differentiate both sides, du, the answer will be equal to minus sine x dx. Now watch, this is what I have, minus sine x dx in the numerator there. So I'm going to bring that integral down here, and I'm going to say minus integral of, check this, I'm going to say 1 over 1 minus cos squared x, and then I must put sine x minus sine x dx together like this. This integral is exactly this one, as you can see up here. Why am I doing this? Because now I want to say this is equal to the integral of 1 over 1 minus u squared du. Remember, du equals minus sine x dx. And then 1 over cos x is actually u. This is what I have. Now I'm going to perform a simple trick here again. Firstly, let me perform factorization of this, which is called difference of two squares. So this is going to be the minus the integral of 1 over, this one here is going to be 1 plus, if you want, or minus u in one bracket, the other bracket 1 plus u, and then we have du. Now looking at this part here, we have to break this one down. And what I'm going to do is the following. Check this out. Minus, and I'm going to put this one somewhere here. And I'm going to say, I want to produce this in the numerator. So I will say 1 minus u plus 1 plus u. Plus u, like this. Notice this is that and this is that. But if you simplify this, the u's cancel. You just have 2 there. 1 plus 1 is 2. So because I don't want to change it, I'm going to put 2 there. So I cancel the 2 at the top, but I'm not canceling. This is going to be all over 1 minus u, and then 1 plus u, and then du. So what am I going to do next is to use what we call term-wise division. I've spoken about it several times. I'm going to take this whole expression, divide into 1 minus u, and then take the whole expression, divide into 1 plus u, as follows. So this is going to be minus 1 over 2. Let me use a bracket here now, and I'm going to distribute the du as well. So it's going to be the integral of 1 minus u all over 1 minus u, and then 1 plus u du, plus the integral of 1 plus u. Remember, there's a plus sign in between there that separates this and that. So I'm going to say divided by 1 minus u, 1 plus u, and then I have du. Then I can close that bracket there. Now, this one here, you can see it simplifies. That takes me to page number 3. Let me move this one up. Yeah, you can see it clearly there. These cancel. Let me put this in brackets and that one also in brackets. You can see that cancels that, so you have 1 there. And that cancels that, so you have 1 there. So I'm going to have 1 over u, 1 plus u. And then here I'm going to have 1 over 1 minus u. Right. So taking it to page number 3, what we have now is the following. Let me move this one down again. Move it down again. Yeah, that should be fine. So what I have now is the following. That integral is going to be equal to, I have minus half outside, and then I have this part here. Let's clean up. 1 over 1 plus u du plus 1 over 1 minus u du. Evaluating this integral, you've seen it from the previous examples so far, that this is just going to be the natural log of 1 plus u, because u is positive, plus, if you like, but this is minus u, so it will change the minus side, the sign there to minus. So this is going to be minus natural log of 1 minus u, like this. Convince yourself that this is correct. Use theta substitution or whatever. Let this be equal to k, for example. And when you do the integration of this sign will change to minus. And I have, let me close the bracket there. I can put a c there now because I've done the integration. All we need to do is simplify now. Right, so now I'm going to distribute the minus 1 outside here. The minus must go in. I'll keep the half outside. And then I take the minus in. This will be minus natural log of 1 plus u, absolute value there. And then the minus will change that sign to plus natural log of 1 minus u, like this, plus c. Now let's write the plus sign first, the term containing the plus sign. 1 over 2, and I'm saying now natural log of, I have 1 minus u minus natural log of 1 plus u. And then if we rewrite this using laws of logs, remember there's a law of logs that says the log of, we're using natural log here now. Let me use natural log. Natural log of m over n. This is going to be equal to natural log of m minus natural log of n. Laws of logs, just remind yourself on that. So looking at this here, it tells me that this is just going to be half of, let me now remove the brackets, plus c, remember, natural log of, and I'm going to say 1 minus u over 1 plus u, like this. Now plus c. Let's go back. What is u? Well, if you look at this one here, u is actually cosine of x. That's u. So now I must put cosine of x and cosine of x here. So this is going to be 1 over 2 natural log of 1 minus cosine of x all over 1 plus cosine of x plus c. I want to simplify this. I'm going to multiply the denominator by the conjugate of 1 plus cos x, which is just 1 minus cos x. So this is going to, and I'll do the same in the numerator. So this is going to be 1 over 2 natural log of, check this, 1 minus cos x in brackets, multiplied by 1 minus cos x. The denominator, I'm going to have 1 plus cos x, multiply this by 1 minus cos x plus c. Right. Taking us to page 4. We're basically simplifying this. We're done so far. We're just simplifying this. Page 4. So we obtain an expression that many people are familiar with. So that is going to be equal to half natural log of the numerator changes to, remember, 1 minus cos x, basically squared, because these two terms are the same. In the denominator, I have, if you do difference of two squares here, expansion, you're going to have 1 minus cos squared x, like this, plus c. Now, looking at this one here, what is 1 minus cos squared x? Is actually sine squared x. You can see it here. It's actually sine squared x. So I'm going to have sine squared x in the denominator. So this is 1 over 2 natural log of the numerator. I'm going to have 1 minus cos of x, and I keep that one the way it is, all over, and I have sine squared x in the denominator, plus c. At this point, it's not necessary to keep the absolute value signs, but there's no harm in doing so, because this term can never be negative, because that is squared and that's squared, right? Now I'm going to put this one as a square of one expression. So that's 1 over 2 natural log of, and I'm going to say now, watch this, I'm going to now say 1 minus cos x all over sine x, and then I'm going to put brackets like this, and I'm going to say squared. It's the same thing, plus c. Like I said, these are not necessary. Using laws of logs, these two can come this way. Remember laws of logs? There's another law of logs that says natural log of m power p equals p natural log of m. So now if you look at this form here, is the form we need, because there we have this form. We have this form with a power there, where our power is 2, so it must come this side. So we're going to have 1 over 2 times 2 natural log of, watch this, now I need the absolute value to be maintained, 1 minus cos x over sine x, and then plus c. Now these cancel, so what I have now is just natural log of 1 termwise division over sine x minus cos x over sine x, termwise division like I said, and this simplifies to natural log of, this is actually cosecant x minus, this is actually cotangent x, if you remember reciprocal trig functions. So this is our final solution then, using simple algebraic techniques, the special one again coming up very prominently in this one too. Right, like I said, I'll bring up another video where I'll evaluate the same integral, but using what we call the z substitution. And I have 2 more examples on the z substitution, so that the concept is thoroughly understood. Right, if you're new to this channel, please do not forget to subscribe, share these videos with friends, support us so that we're able to produce many more videos and support as many students as we possibly can. Right, see you next time.